Hello, everybody. Welcome for being here. And I will wait some minutes so to allow everyone of the attendees to join our session. Today, I will open this session of a live webinar study group named Study Group. And I'm Claudio de Angelis, and today I will speak about Castable attachment, Otica, and Unilateral. In the meantime, I want to remember you that Dr. Gabriele Vaccaro will hold the next live webinar, the 3rd of December, so basically in 2 days, at the same time. Today we will speak about Castable attachment that Retentive will provide you for trying to giving you some solution in your everyday life. Today I will focus on a few of our attachments because our catalog is huge, and virtually it will take me 1 day long to speak about all of them, and today we have less time, and I will only focus on 2. I will present you these 2 products, both in the analogic way and in the digital way, so to understand how we can use them accordingly to our needs. Okay, in these days, digital is the main focus. Everyone is talking about digital, but we need to never forget the analogic way. Retentive has the big pleasure to work basically all around the world. At least this number of countries is increasing every day, and of course, for sure, we are in all the continents. We are available in all the continents. We have, as I was saying you before, we have a vast choice of attachment, both direct attachment on roots, on natural roots. The name of those are spherical pivot line. We can switch to implant with the Ferroline family. Those are direct titanium attachment, which will offer to our denture a retention by means of a retentive cap, which is embodied in the denture, in the patient denture. Somehow the evolution of the Ferroline family is the OT equator, which is also a direct titanium attachment, and also this last new attachment, which is a low profile attachment, works with a retentive cap and a housing embodied in the patient denture. We also provide our customers a different kind of attachment. For example, Otica is the one. I think it should be the first attachment we invented since 1983, and today is still one of our, let's say, best buy attachment. And of course, then the evolution of our society lead us to create new kind of geometries. For example, OT strategy, which is a extracoronal attachment, an axial extracoronal attachment, and also other like bars, like bars which can be both resilient or rigid bars, always working with a retentive clip. Okay. The basic concept is that we work with something which is fixed in the mouth and then a retentive cap or clip which is embodied in the metal framework of the patient denture. And the idea is basically the same. Then we evolve this idea in many shapes, in many dimensions, but this is our basic idea. Also in the Castables, we have an interesting evolution, because today we also have Castables which can be combined with pre-milled spheres. The one is the Otica Techno, and for example, this one is the bridge between the analogic and the digital, because for example, Otica Techno can be used both in analogic and also in the digital field. So as you can see, we are always struggling to be updated and to be on time with the needs of the market. Last but not least, again, the Octi Equator family, which was declined in a vast number of attachment, from the very simple one, which is the red one you can see on your screen, on the upper side of your screen. The red one is the Castable Octi Equator. On its left, you can see the threaded sphere of the equator, which can be screwed directly in a bar for bar-supported denture, removable dentures. The one I already showed you at in the middle is the OT equator as direct attachment. And the last one below on the right is a Castable, which is also available for CAD-CAM. And this is basically a device to create passive bars, always in the removable field. Okay. Let's see a bit how you can profit of our catalog. Our catalog are available online in different in many languages, mostly in English, but we have French, German, Portuguese, Russian, and so we also in this field we are working really hard to provide you to be more close to you in your native language, and you can find them on our website. Let's see the structure of the catalog, how you can use it at its best. In the white part, you can see the attachment, the presentation of the attachment, and below the accessories for this specific product, for this specific attachment. Meanwhile, in the blue part, you can see all the clinical part concerning this attachment. So I mean, how you use this attachment, which was presented in the white part, in the white side of our catalog, how you can use it in the clinic, so with the patient directly. Okay, and below in the blue, in the green part, you can see how to use, how to process this attachment in the laboratory. Okay, so this is a very powerful tool. Our catalog is a manual mostly. It's a very powerful tool to understand what you have in your hand or what you may need accordingly to your needs. And most important thing, how to use it, both in the mouth or in the on the model. Okay. Basically, this slide show you the, I dare say, the 80% of the knowledge of Retentive 3. No, I'm joking. Basically, is the grounding idea of our society. As I said you before, we have a sphere which is somehow cemented or screwed in an implant in a bar into the mouth. And over this sphere, we have a retentive cap which goes in the undercuts of the sphere and provide retention. This female cap is made of elastic, biocompatible materials. So what we can achieve with those plastic is a retention of the removable denture, which otherwise is able to, as a complete denture, simple complete denture, is able to move to navigate over the gingiva, as I always say, like a boat over the gingiva. And with this device, with an attachment, we provide retention to the denture. Okay. This said, here you can see a little bit the difference between Retentive 3 in the right part of your screen, and on the left part of the screen you can see our competitors. Basically, we have bigger caps, slightly bigger caps, but, and this is the big difference, the huge, I dare say, difference, we have elastic materials. On the other hand, our competitor have only rigid materials. Rigid material can work, giving to the behavior of the plastic, only in the friction zone of the sphere, so it has the maximum diameter. The retentive elastic cap from Retentive 3 can work on a bigger surface, the equator, but also the undercuts, the lowest part of the sphere, and provide a better retention. Not only a better retention, but also a better durability of the retention, because if you work on a minor surface, you run the risk to wear out the surface, to consume, to damage the surface. And once you damage the maximum diameter of the sphere, you lost your retention. If you work on a major surface, you reduce the stress over the sphere. This said, you have also a softer cap, which will be less aggressive over the sphere, and the result will be you protect what is vital of this system, I mean the sphere. The sphere, I remember you, is cemented or screwed in the into the mouth. So it's it's more difficult to repair, to change a sphere, than to remove a cap, change a cap, and put into the denture a brand new fresh cap. Okay, this is the idea. So Retentive 3, all the systems of attachment by Retentive 3 are designed to preserve as much as possible the sphere. Okay. Also, to improve this kind of protection, I strongly suggest you to use the retentive cap inside a metal housing, because if you can pay attention between the interface, between the pink cap and metal housing, you can notice a tolerance. This tolerance allows the cap to open itself while it goes in contact with the sphere. So it will open itself a bit, overcome the maximum diameter, and close again on the undercuts. Okay, like a hook, basically. We can use the elasticity of our cap the same way as the elasticity of a hook of a metal frame, for example. So it's very important to use the metal housings for the caps. If not, you just embody the cap into the resin, which is on the pink resin of the denture, of course, which is rigid, which do not allow the cap to open itself and close again on the undercuts of the sphere, and you will basically keep it stuck, keep it blocked, and the result will be a more rigid sphere, and over time it will be too much aggressive over the sphere. So that's the rationale of the metal housing. It's not just for adding price to our denture. It has a meaning, and you need to know this. This said, we have a wide choice of retentive caps. On the left side, you can see the 2.5 family. So this is the 2.5 family. And on the right, you can see the 1.8 family. Below, the last 4 caps are made of 2.2 as an internal diameter, because those are compatible with many spheres which are already in the market, or in case when an old Retentive sphere, which was originally of 2.5, over time has reduced the diameter, and you need again to recover the retention of our denture, of the patient denture, sorry, and you are not forced to change the sphere. You just change the cap by using one with a internal diameter reduced. So the last 4 are the undersized internal diameter cap. You have the 2.2 on the left side and the 1.6 on the right side. The micro undersized caps are available only in 2 colors, the aqua color and the orange one. Please remember that the black cap you find in the middle are only for processing, so they must be used only in the laboratory. So why we can offer you different retention? Because each cap is made of a different material. I remember all our material are biocompatible. We have all the approval from FDA, Italian Ministry of Health, and our caps are tried. The material biocompatibility, of course, are investigated by third-party laboratory, which are GMP, GLP, sorry, good laboratory practices. So they have the maximum standard in terms of quality assurance. Okay. Okay, let's go into our first attachment, Otica. As you can see here, you can notice that it has a various setup. We have the straight bar, which the sphere is made of 2.5. The green color here is to show you that it is in 2.5. Remember, we have also the micro size of this attachment, which will be in red color. The green and the red are of castable plastic. Okay. So you have the straight bar, but also the beveled bar, and also the single sphere. Let's see one of those, how we can use it. Please, I want to stress over this point. Do not misunderstand Otica. Otica is not a unilateral attachment. Okay. You should always use Otica on both sides of the arch, okay? on the right and on the left side. We have OT unilateral, which is a unilateral attachment, and we will see it in a few minutes. The only thing I want you to remember is that Otica is not a unilateral attachment. It has not the proper design to be used as a unilateral attachment. We have an unilateral attachment, which is called, of course, OT unilateral. Let's go into the Otica. Let's see a prosthetic case with Castables. It's a very simple attachment. In the laboratory, you broke the bar, the one with the angled arm, and accordingly to the occlusal plane, you always need to understand which is the occlusal plane of the patient, and by means of a parallelometer, you place your attachment in the distal area of the crowns, to be cast. You place your attachment on, again, both sides of the maxilla in parallel between them and perpendicularly to the occlusal plane. This is a very important thing to remember. You always need to investigate the occlusal plane of the patient. This said, you just connect it to the crowns, paying attention to this kind of flat surface. It's like a threshold, it's like a seal, call it as you want. The idea is that you need to preserve this part because it has a strong meaning. Sometimes, even in Italy, I noticed that dental technicians cut this arm because they think it's too long, it's too far from the crowns. I have fear that it will broke or something. The biggest mistake of their life. Okay, this attachment was designed to answer some mechanical stresses, and in doing this, we do not need to modify it. So always respect this arm. I will show you why with a very interesting video. This said, after connected to the crowns, we cast, the dental technician put the sprue, they cast their crown and the attachment. I suggest to always prepare at least remember 2 crowns. Never prepare, doctors, please never prepare only 1 crown. Always connect 2 crowns together, okay? 3 is better, 4 is even better, but the minimum is 2. And after the casting, the technician just cover with aesthetic ceramic, composite, whatever, okay, the crowns. Note that also here I need to respect this flat surface. Why? Because we need not to create a lever which will destroy our teeth covered by the crowns. Let's see how to duplicate and how to produce the metal frame. It's very simple. We took the, I'm a dental technician, so I say we. We took our model with our crowns and the attachment, of course, and we put on top of it the positioning ring. You receive it with a set of castable metal, with a set of castable housings, okay? You have it inside, and you place over the sphere. We remove all the undercuts with wax, and we duplicate it so to produce a investment material model. After that, you can see we just duplicate the ring, not the sphere, and mostly not the retentive cap. This is another huge mistake too often dental technicians do. They put the retentive cap over the sphere and they duplicate it. The second biggest mistake of their life. Because the retentive cap is not intended to be duplicated after when you produce the metal frame, the tolerances will not be correct. So to do a state-of-the-art job, you need to duplicate the ring, the positioning ring here. And after that, you just, as usual, as your normal everyday life, you just need to modelize the design, the metal frame. By doing this, remember to put on top of the ring the castable housing, okay, which will be connected to the metal frame. You do all your works, modelization, all your nice job, okay, and you cast your metal frame. This is the reason why I stress over the horizontal part of my attachment, over the why to preserve the arm of my Otica. Sorry, the video didn't start. Okay, this is why. Okay, basically I have produced everything and I have produced also the metal frame. Look here. Into the target, you can see how the metal frame has a rest over the horizontal part of my attachment. If you do this, you do a correct job. Why? Because on the distal area, you have the chewing force. Around the sphere, you have the elasticity of the retentive cap, and very close to the crown, you have the fulcrum of all this system. By doing a proper job, all the stresses will be located over the fulcrum, which is very close to the crown. If you do not respect the arm of my attachment, what will happen? The fulcrum will move around the sphere. You have always in the distal area the chewing force. The fulcrum will move around the sphere in this area. The fulcrum will be here, okay, and the resistance will be my teeth. So I reverse the lever, and in this case, it will become a kind of hook that will extract my crown and consequently the roots, the teeth on which my fixed part of the denture is located. Okay, it's just a geometrical matter. If you do a proper job, the fulcrum will be here, and it's perfectly correct. If you cut this part because you fear that it's too far from the teeth or you don't have space or whatever, you will do a huge mistake because the fulcrum will move here around my sphere, and then this will be a how can I call it, like a clamp which will extract my teeth. Okay, remember this. Come on, next slide. Okay, so basically I give you the basis to understand Otica. I remember it is available in 2.5 and in 1.8 size, okay? The 2.5 is the green, the red one is the 1.8, the micro size. And this said, you can use as you want. For distal free saddle, bilateral, remember it's a bilateral attachment, removable dentures with a metal frame. You can use it as a single sphere on top of the bar, on route. You can basically use it as you wish. Gives you the freedom to be used as you wish, as you need, as your patient needs. Okay. A smart tool to remove and to replace the caps. This is basically a double-sided tool. It has a black hook with it you can go into the cap and rotate. By rotating, you extract very easily from the metal housing, from the inside of the denture. And by changing the tip, I remember it's a double side. You can see here you have the hook, and here you have the insertion tip. You take the cap and you place it inside the metal housing. It will take you 30 seconds to remove a cap. 1 minute, okay. This is also the meaning of the metal housing. If you don't have a metal housing inside your denture, you need to remove the cap with a bar. You need to make again space inside your pink resin, and you need to reline your denture with all the problems you may have, with all the time that you need to do for this practice. If you have a metal frame, metal frame or a metal housing, or at least a single metal housing, it's a job of 2 minutes. Okay, very easy, and you have no possibility to have problem, mistakes, or whatever. I approach to the CAD-CAM part of my presentation. By doing this, I show you the Otica Techno. At this moment, I use it in an analogic way. We have the same concept as the Otica Castable version. Here we have a Castable arm, which will be connected to the crown as before. The only difference is that I do not have a sphere here on this part of my arm. I always need to preserve the arm, the horizontal area. I need to place them in parallel between the two sides of the mouth and perpendicular to the occlusal plane. But once I cast it, I'm very free to polish. I do not have the sphere here. I do not risk to damage my sphere with a bar during the polishing, during whatever I need to do as dental technician over this attachment, okay? I can produce my aesthetic part. Of course, for placing this, I have a proper parallelometer key. Sorry, I remember this. I have a proper parallelometer key. And at the end, I just glue the threaded titanium sleeve with the attachment screwed in it. I just glue it inside the hole, the calibrated hole of my arm. Okay, you can see we can use it. Yes, always remember to preserve this flat surface. And Otica Techno, again, as the Otica Castable, is available in micro size and normal size. The threaded sleeve to be bonded and arm are perfectly the same for the two versions. Okay. Remember this flat surface, and this is my attachment after I glue inside the hole of my arm the threaded sleeve. I can remove it and I can replace it in case of wearing, in case of damage. I can always recover my system over the years, okay? And let's see how to use Otica with a CAD-CAM. So I just pick up the Otica Techno, and as I promised you, you find it into the libraries of your software. We are inside the main software houses, okay, in the market. And if not, if you have not the attachment updated in your dental design software, you can, by applying the following link, please take out your phones and have a photo of this slide. You can find all the libraries that you need. As you can see, we are into the biggest 3D software houses: TrueShape, Dental Wings, ExoCAD, AGS Solution, 3DM. So you can find our attachment by applying this link. It's a form where you need to give your mail, basically, and then you can download freely. And into the download, you will have also a video on how to install by yourself what you have just downloaded. Okay, so again, take out your phones and have a picture of this slide. Okay, let's see the CAD-CAM case. We start from a traditional impression. It's not a totally digital workflow. The doctor prepared the frontal teeth, took an impression, a very good quality impression, and the laboratory produced the model, the master models, and put it in the articulator. They scan everything, the old situation, the new situation of the prepared teeth, and they also, with a proper vertical occlusion, they put them in a digital articulator also. Was some years ago. They do this study case. Today it's even more easy, and the workflow is more easy to do. But at the time, I think this case has at least 5-6 years. The technician, Cattin and Junki, they did a great job with, for example, they worked with ExoCAD. What they did, they just design the proper teeth setup. Again, always remember that a patient needs to chew, needs to smile. The patient needs a proper made, well-made denture. A patient do not need an attachment, okay? By saying this, what I mean? I mean that first you need to have in your mind what is the denture the patient needs, and after made this, accordingly to this, we choose the attachment. Again, too often I see technicians, dentists that have anxiety to choose the attachment to place inside the mouth of this patient, even before to understand which is the best denture to make this patient. It's another huge mistake. Patient, again, do not need an attachment. Patient need teeth, okay? Once we understood the best denture to make, then we choose an attachment. So both in the analogic and in the digital, we always think first about teeth and then to attachment. Because in this way, I will not mistake the choice of my attachment. I have all the information to choose the proper attachment. Retentive offers a huge amount of solution, but each of these solutions need to be applied properly. We have micro and normal size sphere, and we need to first understand which one fits the best to the denture. Okay, this is another take-home message I want you to remember today. So again, they produce a denture, the teeth, they made the teeth set up, and then below of it, they choose the correct attachment. In this case, they use the OT Techno file for a milled structure. You can see they produce a milled structure. I don't know if in titanium or alloy. I think it should be a alloy, yes. And they also produce they print in white acrylic the teeth setup. So to make a check, to double check in the mouth if the work was properly designed. In this case, they didn't use the threaded sleeve to be bonded inside the attachment, but their CAD-CAM machine allowed them to thread directly, to tap and die directly the whole of my OT Techno file, and they just use the family of attachment to be screwed directly into the metal. Okay, the teeth set up in white, the structure in metal, and from the teeth setup, you can see the switch between digital and analogic. From the teeth setup designed in digital, they produce a silicon mask, so to understand perfectly all the dimension, both vestibular or palatal, and occlusal, of course. They did the trying in the mouth with the doctor. You can see the placement of the attachment in the below on right, the try-in also of the white teeth setup. And when everything was approved by the dentist and by the patient, they produced the aesthetic coverage. Please appreciate also the finishing of the structure, but always keeping safe the arm. So everything should be made with a logical workflow, okay? After that, they duplicate the model as I showed you before. So again, the positioning ring around the spheres, the duplication, and the production of the investment model. Over the duplicated ring, they place the Castable housing, and they just produce the metal frame in wax. After that, they apply the screws and they cast with a traditional casting machine, the metal frame. I show you a tip, a trick, not a tip, a trick. The insertion tip this time, the insertion tip of the retentive caps, the blue tool I showed you a few minutes ago. The insertion tip is a calibrator for the housing, for the metal housing. So with this, you can understand if it's too if it has not enough tolerance here, because it will not touch the top of my box, cast box. And you just need to regroove a bit the inner side of my box. Once the tip can go fully into the space and touch the top of my cast box, you have the assurance that everything was made correctly and you have the proper fitting for the retentive cap. This is the tolerance you need to have so to make the cap work properly. Okay. Remember, always available for micro and for normal size. Micro in red and in green, the normal size. Your crucial stop. Again, I will stress you over this theme. So everything was checked in the master model. The accuracy, they are really crazy about accuracy. They investigate everything, and as you can see, you have the retentive cap, the black cap, because it's for laboratory. You have the black cap fully inserted into its housing. And after that, you just complete the saddle with the orthopedic pink part and the teeth setup, as you already checked it before in the mouth. So basically, you finish your work. Let's see a double case with Castable and with CAD-CAM. It's always a work by Cattin and Junki, and you can appreciate how the patient was the first day. The doctor decided to remove the two incisors. They made a brand new teeth setup, and they made a try-in of this teeth setup. After that, the doctor placed the implants into the bone after the recovering of the gingiva, after the osseointegration. They took a new impression, so to produce a bar. Over this, they produce again a complete and a new teeth setup, because if you remember, this one was just a shortened teeth setup, okay, for the provisional. They completed all the teeth setup, removable and a removable denture, supported by a bar. The bar, of course, is in connection with the implants. This bar is made in analogic, and to preserve, to pay attention to costs, to the manufacturing costs, they produce it in Castable. In this way, they produce a Castable bar with a milling machine, which will have a high accuracy over the connection sides, but without the attachment, because they just place some, let's call half seating placement areas for the OT equator, but the Castable OT equator. You can see here they just glued the OT equator over the bar. Okay. They regrooved with a parallelometer the bar. They completed the modelization where they feel it was necessary, and they place also a two distal attachments here and here. The OT strategy, if you remember, the second one in Castable is the OT strategy, and they place on the distal area of the bar. Sorry, again, they produce a silicon mask accordingly to the teeth setup, so to understand the prosthetic space. So remember, always the patient needs teeth to smile, to chew, to have a social life. But we need to do it correctly first, and then to choose the proper attachment to be inserted into this volume, this prosthetic volume. This photo is to show you that laser melting has not yet a good quality of production, mostly over the sphere. I can allow this kind of imperfection over the bar because after the laser melting, I will regroove it, but I cannot regroove the sphere. I cannot polish the sphere, otherwise I will lose the retention. So if you need to lower the manufacturing costs, the suggestion is to do this kind of work, not a laser melting of the sphere. It's better to produce a castable bar so you have a good quality of connection over the implant, and to glue, just simply glue the attachment on top of it. So you can have a economic bar, but without compromise the precision. Here you have not at all a reliable bar, mostly over the spheres areas, okay? So, okay, the cast bar, they go with the finishing, and you can see how they didn't touch the sphere here. Never polish, never touch the spheres with bars, just crystal beads with at low pressure while you remove the bar from the investment material. Okay, back to the digital. They rescan again the model with the bar, and they produce the contour bar. You can see how they took care to leave enough space for the metal housing to be inserted, the vertical one and the distal one, 1 and 2. So to fix inside the contour bar the metal housing for the attachment. Here, the fitting of the bar and the contour bar from the gingiva point of view, let's say, and you can see how they are into a perfect polishing of the bar, because you always need to remember to give a well-polished bar, okay? The precision over the analog is also a vital part of this bar. And after that, you just need to finish your denture and to deliver the processes. Let's see how to work on a complete digital bar, for example. Remember, before I told you, in the case with Otica Techno, they used a directly threaded bar, and they use this family of attachment, which is a 2.0 standard thread family. So this family can be screwed directly into the bar when your machine, where your CAM machine can produce a thread, or if not, if your CAM machine produces only a hole, you can just glue the threaded sleeve with the 1.6 family. Okay, the sleeve is the same for all the sides of this family of spheres. So on your left, you have the threaded sleeve to be bonded family of attachment. On your right, you have the direct screwing family of attachments. Let's see a more digital work. Here you have a pre-visualization software. You put the vertical occlusion jig. You just place your teeth over it. So to make a pre-visualization for the patient benefit, so the patient can better understand what will be what it will she, in this case, she will receive at the end of the treatment. You can also produce with this a train printed denture, a very quick printed denture. This case also has some ears, and at that time didn't exist the white resin to be to produce the provisional, the pre-visualization denture. And here you can see how after the intraoral scan and after the scan of the teeth setup and the lower jaw, you can see how the dental technician, which in this case is Carlo Borromeo and the doctor is Luca Ortensi, you can see how the dental technician pay attention to produce the bar and consequently place the attachment accordingly to the occlusal plane. You can see here how the bar is in compliance with the occlusal plane. They are parallel, basically. The plane of the bar and the plane of the occlusal are in parallel between them. Okay, this is a very important thing. This is basically what you already made in your laboratory with the parallelometer. It's the same story, okay? The same concepts are true in the real world and in the digital world. Okay, this said, with the software, you have a lot of possibilities. You can see in transparency, the denture, you can understand the space, the prosthetic space. Again, this is what you made before with a silicone key of the denture. Here you have directly the transparency of your denture. So again, the two things are true in the real life and in the digital life, okay? You place your attachment accordingly to your bar. You check the distance, the spaces, and after that, you can just screw into your bar the threaded attachment. In this case, you have the 2 millimeter family of direct screwing attachment. You have a thread inside your bar. The microsphere, you can use it in a vertical way, but also in the horizontal way. In this case, in the vertical, you use the Otica microcaps. In this way, in the horizontal, in the distal area, you can use the OT strategy cap. After that, they produce the counterbar. They check again with the printed pre-visualization. They check the prosthetic space, the bar, and they finish basically the work. Let's talk about the second attachment. The OT Unilateral is a very smart, and this is available only in Castable, but is a very smart attachment because you use it as unilateral attachment, so on only one side. But remember, the concepts are always the same. The horizontal area here must be respected, even if you have two spheres, because you can see how the two spheres by working together allow a vertical resilience of the metal frame without stressing my teeth. So again, here also at least 2 crown, 3 is better, 4 is even better. And again, parallelometer key. I put the attachment in compliance with the occlusal plane, in perpendicular with the occlusal plane. I put again the positioning ring over the vertical sphere, and look, pay attention, check this out. you place the metal housing directly on the master model without duplication, because this attachment was intended to be used directly over the master model without making duplication. So you place your attachment over the crown, you place the positioning ring, and on top of it, you place the castable housing. Pay attention to connect the castable housing, only the castable housing, to the metal reinforcement in yellow, and to apply screws on the metal housing and the reinforcement, and separately to put a screw to the crowns and the actual attachment. Remember to remove the positioning ring. This one should not go together along with the attachment. It should be removed. You put what you just made in the same cylinder in the same investment material. So you have same contraction, same shrinkage, and the two pieces will always fit the best because they have the same expansions and the same shrinkages. If you duplicate, you made two casts and you may have two different results. By doing this with the same, within the same cylinder, within the same investment material, you are sure you have the same result. So it is fast, it is simple, two pieces in one cast. And this is the work done, okay? You are a lover of a duplication, you do not trust doing it in one way, okay. You just produce the metal crown with the attachment as we said. You put the ring on top of the vertical sphere, you duplicate the model, you transform it in investment, and you place your your castable box on top of your duplication. You produce, you design the metal frame, you cast it, and after that, you continue with your work. You finish the frame, you polish it, you insert the cap, and you just complete your work. Remember always to respect the geometries. Again, in this video, remember to respect the fulcrum area. So let's see a case with the two attachment, Castable. Again, technician Cattin and Giunchi, they needed to increase the vertical dimension of this patient. They made a temporary bridge and also a bite on the lower teeth. You can see the new bridge on the upper and the bite on the lower. On the lower jaw, the patient has also a removable denture with hooks, but basically the vertical dimension was destroyed. And by increasing step by step, because you can never increase in one shot, the vertical dimension of a patient will be very risky. They just produce a bite, so to go step by step with the final vertical dimension. They made a brand new denture on the lower jaw once they reach the correct vertical dimension, and they made also a new wax rim for creating a they already made this wax rim to create a correct to register the final new vertical dimension, and they produce the removable denture on the below, and also the patient, the doctor, sorry, placed the implants. They made a bar to check the compliance between model and the mouth of the patient for the implant positioning. And after that, they produce a bar. They were forced to produce a cantilever here in this case because the patient has a correct amount of bone only on the frontal area. And this is how they determined the correct cantilever. Basically, this was a Brownian intuition on how to choose how to create a correct cantilever in the distal area. Basically, you trace a line between the most frontal teeth, the most frontal implants, and you trace a line, parallel line, between the last implant. Those two lines need to be parallel between them. You investigate the amount of distance between the two lines. You can see it in green. And then you can put the same amount of distance in the distal area, 1.5. So the distance between the two lines, you can put the same distance in the cantilever by a maximum of 1.5. And in this way, you can appreciate on the right side of your screen, you can reach at least the first molar, which is more than enough. So they investigate the occlusal plane as before with the parallelometer. They produce a silicon mask and also the bar. In this bar, they place in the frontal area 3 Otica single Castable spheres. And in the distal area, you can see the what happened? Sorry, my computer get crazy. And in the distal area, they place the unilateral attachment on both sides. You can see how they respected what we said before with the cantilever. All the attachments are placed in compliance with the occlusal plane. They finish the work with the Castable, with wax. They complete perfectly the bar. Also, you can see all the spheres are perpendicular and in parallel between them. They cast the bar, polished, and produce the counterbar again with the Castables components with the Castable housings, by always respecting the prosthetic space. The fitting check between bar here. On top of the bar, there is some white spray to investigate the pre-contacts, okay? And so they check the fitting between the bar and the counterbar. And after that, they produce the aesthetic coverage. Remember always the space for cleaning the bar in between. And after this, the work delivered, they restore the vertical occlusion and they give a proper aesthetic to this patient. So I just finished. Thank you for your attention. And before you leave, I remember you the next session, December the 3rd, same time at 12 Rome time. I will be grateful with you to attend and to listen to Dr. Gabriele Maca. Thank you for being here, and you will find also the registration of this webinar in next few days into our website. So if you need to see again something, you can just go and find out this live webinar. I remember you, 3rd December, Dr. Gabriele Baccaro. Thank you for being here, and hello to everybody. Bye-bye. Ciao.